Welcome everyone. I'm excited to kick off our presentation today. We're going to explore the fascinating world of computer systems. This is the first slide, so I just want to give you a quick overview. We'll be discussing what computer systems are, how they work, and why they matter. So, let's get started and dive into this engaging topic together. Let's take a look at the contents of this presentation to get an overview of what we'll be covering. We start with the basic question: what is a computer? Then, we'll explore the design of a computer system, which helps us understand how all the parts work together. The IPO cycle, or input process output cycle, is fundamental because it explains how data flows through the system. Next, we'll discuss the various operations a computer performs. Moving on, we'll examine the input and output units, which are essential for interacting with the user. The storage unit, along with primary and secondary memory, shows us how data is stored and retrieved. The central processing unit, or CPU, is the brain of the computer, and it includes important components like the control unit and the arithmetic logic unit. Together, these parts work seamlessly to perform complex tasks. Understanding these elements helps us grasp the overall functioning of a computer system. A computer is essentially a machine that can be programmed to perform a sequence of tasks automatically, whether they are arithmetic calculations or logical operations. When we talk about modern computers, they are capable of running a wide variety of programs, which are sets of instructions that enable them to do many different things. So, a computer system is not just the hardware, like the CPU, memory, and storage, but also includes the operating system and peripheral devices that connect to it. Now, let's talk about the key characteristics that make computers so valuable. They are incredibly fast, much faster than humans at processing data. They are also highly accurate, with minimal errors in calculations. Cost-effectiveness is another important point. Once set up, they can handle many tasks efficiently, saving time and resources. Computers never get tired or distracted, they are diligent, and they have a huge storage capacity for data and information. Furthermore, they are versatile, meaning they can be used for countless applications, from simple calculations to complex simulations. They save us a lot of time through automation, handling repetitive tasks quickly. Security is also a feature, as they can be protected with various security measures to safeguard information. However, computers do have limitations. They lack intelligence, what we might call zero IQ, meaning they can't think or understand context like humans. They don't make decisions on their own. They rely entirely on the instructions we give them. And importantly, they depend on external power sources like electricity, so without power, they are useless. Understanding these points helps us appreciate the power and the limitations of computers, which is essential as we explore more about their role in our lives and the technology around us. Let's take a closer look at how a computer system is designed. Essentially, a computer responds to a specific set of instructions in a well-defined way. These instructions are organized into what we call a program, which the computer executes to perform various tasks. Now, when we talk about the physical parts of a computer, these are known as hardware. Hardware includes all the tangible components you can see, touch, and feel, like the CPU, memory, and peripherals. These form the foundation that allows the computer to operate. On the other hand, software is a different story. It refers to the collection of programs, procedures, and documentation that tell the hardware what to do. Software is what makes the hardware useful because it provides the instructions and logic needed to perform specific tasks. Connecting these ideas, the overall design of a computer system hinges on how hardware and software work together. Hardware provides the physical platform, while software gives it purpose and functionality. Together, they form a complete system capable of executing complex operations efficiently. Let's take a closer look at the IPO cycle. This cycle is essentially a computer procedure used for processing information. Think of it as the fundamental way computers handle data to produce useful results. It's a critical process because, without it, users wouldn't be able to get the outcomes they expect from their systems. The IPO cycle is made up of three main elements: Input, process, and output. First, input is about feeding data into the system. This could be anything from typing a command to scanning a barcode. Next, the process is where the computer works on that data, performing calculations, sorting, analyzing, or transforming it. Finally, output is what we see or receive after the processing, like the result on your screen, a printed document, or a saved file. Understanding this cycle is key because it connects to the overall theme of how computers operate efficiently. Each step depends on the previous one, and together, they ensure the system delivers accurate and timely results. So, whenever we talk about computer operations, remember this cycle: input, process, output. It's the backbone of all digital processing. Now, let's take a closer look at the 5 basic operations of a computer system. First up is inputting. This is essentially how we feed data and instructions into the computer, like typing on a keyboard or clicking a mouse. It's the starting point for any task we want the computer to perform. Next, we have outputting. This is how the computer shows us the results of its work, whether that's on a screen, through a printer, or via speakers. It's how we see or hear the outcome of the processing. Processing is the core activity where the computer performs calculations, comparisons, or other operations on the data. Think of it as the brain doing the work behind the scenes to transform input into meaningful output. Storing is about saving data and instructions so they can be accessed later. This could be on a hard drive, a memory card, or cloud storage. It's essential for managing information efficiently. Finally, controlling is about managing the sequence of these operations. It makes sure that input, processing, output, and storage happen in the correct order and at the right time. This control flow keeps everything running smoothly and efficiently. Together, these operations form the foundation of how a computer functions, enabling it to perform complex tasks seamlessly and reliably. Let's talk about the input unit. This is a crucial part of the computer because it's responsible for accepting instructions and data from outside sources. Think of it as the computer's way of listening and receiving information from us or other devices. Once it receives this information, the input unit converts it into a form that the computer can understand and process easily. This step is essential because data and instructions often come in formats that are not immediately usable by the computer's internal systems. Finally, after the conversion, the input unit supplies this prepared data and instructions to the rest of the computer system for further processing. This flow from input to processing is fundamental to how computers operate. Without a reliable input unit, the system cannot function effectively. So, in essence, the input unit acts as the bridge, ensuring that what we send to the computer is correctly received, converted, and passed along for processing. Now, let's talk about the output unit. This is a crucial part of the computer system because it deals with the results that the CPU produces. Essentially, once the CPU has processed data, the output unit takes these coded results and converts them into a form that humans can easily understand. This translation is important because raw data from the CPU isn't always in a format that's immediately useful or recognizable. The output unit acts as a bridge, turning these results into meaningful information. Finally, it supplies this converted data to the outside world, whether that be on a screen, printed on paper, or sent to other devices. So, in the bigger picture, the output unit ensures that the work of the CPU is communicated clearly and effectively to us, the users. Now, let's talk about the storage unit. When a user enters data using input devices, the computer system needs to store this data somewhere. That's where the memory or storage unit comes into play. Think of it as the computer's filing cabinet, where all the data is kept until it's needed. The storage unit doesn't just hold data. It also uses a set of pre-programmed instructions to transmit this data to other parts of the CPU when necessary. This ensures smooth and efficient processing. It's important to understand that all computers have 2 main types of memory: primary memory and secondary memory. Primary memory is faster and directly accessible by the CPU, like RAM. Secondary memory, on the other hand, includes devices like hard drives and SSDs, which store data for the long term. Recognizing these two types helps us see how data flows and is managed within the computer system, tying back to the overall theme of how computers process and store information efficiently. Primary memory, also known as main memory, is the type of memory that a processor or a computer accesses first or directly. It plays a crucial role because it allows the processor to quickly access the data and instructions needed to run applications and services that are currently active. Think of it as the computer's workspace, where everything being used right now is stored temporarily for fast access. Primary memory is made up of two main types of memory technology: ROM, which stands for read-only memory, and RAM, which is random access memory. ROM is non-volatile, meaning it retains its data even when the power is off, and is mainly used for firmware or permanent instructions. RAM, on the other hand, is volatile, so it loses its data when the power goes out, but it's much faster and is where the active data and applications reside while they're being used. Connecting this to the overall theme, understanding primary memory helps us see how a computer manages its immediate tasks efficiently. It's the essential bridge between the processor and the data it needs right now, making everything run smoothly and quickly. Let's talk about secondary memory. Now, this is a type of storage that the CPU can't access directly, and it's also non-volatile, meaning it retains data even when the power is off. Secondary memory typically offers much larger storage capacity compared to primary memory, and it's also more cost-effective. That's why we often refer to it as permanent storage. You'll find examples like USB drives, DVDs, CDs, and Blu-ray discs, which are considered removable storage media. These are portable and easy to take with you. On the other hand, we have fixed storage media like the hard disk drive and floppy disk, which stay inside the computer and are used for permanent data storage. Understanding these distinctions helps us see how data is stored and accessed in different ways, supporting the overall theme of how computers manage and store information efficiently. The Central Processing Unit, or CPU, is essentially the brain of the computer. It's made up of electronic circuits that execute the instructions in a computer program. Think of it as the control center that makes everything work smoothly. The CPU handles the basic operations like arithmetic calculations, logical decisions, and controlling how data moves around. It also manages input and output operations, which means it communicates with other parts of the system to get data in and send results out. A key point to remember is that the CPU is different from external components like main memory or I/O circuitry. They work together, but the CPU is where the main processing happens. Inside the CPU, there are two crucial parts: the control unit, or CU, and the arithmetic logic unit, or ALU. The CU directs the flow of data and instructions, while the ALU performs all the calculations and logical operations. Understanding how the CPU works helps us see the core role it plays in making computers function efficiently, tying into the broader theme of how hardware and software work together to process information seamlessly. Now, let's take a closer look at the control unit, or CU, which is often compared to a traffic police officer. Its main role is to manage and coordinate the flow of instructions and data within the CPU. Think of it as the system's manager, making sure everything runs smoothly and in the right order. It directs the movement of data between the different parts of the CPU, ensuring that each operation happens at the right time. This coordination is crucial because without the CU, the various components wouldn't work together efficiently, leading to confusion or errors. So, in essence, the control unit is the brain behind the scenes that keeps the entire system functioning seamlessly. It's a key piece in understanding how a CPU orchestrates all its operations to perform tasks effectively. Let's talk about the arithmetic logic unit, or ALU for short. This is a crucial part of any computer because it's the component responsible for performing both arithmetic operations, like addition and subtraction, and logic operations, such as comparisons. Think of the ALU as the brain within the CPU that handles these fundamental calculations. In fact, the ALU is considered the building block of the CPU itself. Without it, The computer couldn't process data or make decisions. Modern CPUs, however, have incredibly powerful and complex ALUs that can perform a wide range of operations efficiently. It's also important to note that alongside the ALU, modern CPUs include a control unit, or CU. The control unit manages the flow of data and instructions, coordinating what the ALU does and ensuring everything runs smoothly. So, in the context of what we've discussed so far about how computers process information, the ALU plays a vital role in executing instructions and enabling the computer to perform its tasks. This integration of the ALU and control unit is what makes modern computing both powerful and versatile.